Hello everyone, my name is Members Grievin and I'll be taking you through the machine learning assignment 4, which is paper review, and I'm in group 5D, and I happen to have reviewed a paper from the reference here from King Saud University. It's about fish disease detection using image-based machine learning techniques, and I'll be relating it with my project. I think we can start from the process. We had planned that our project is about fish disease detection. We are trying to train a model which can capture a fish, an image of a fish, and tell if the fish is infected, or if the fish is unhealthy, or if the fish is not infected. So the process will be inputting an image of a fish, then resizing it, then contrast enhancement. Then after we shall be having color space conversion. After that we go for image segmentation, then feature extraction, then support virtual machines, SVM, and then the output. The model should be able to tell us if the disease is infected or not. So if you have to explain the steps, we need to always resize all the images with our model, because it increases the efficiency for the process. And we use the cubic spline interpolation for all the resizing of the images. If it takes an image in, whether big or small, it has to resize it to a standard size. Then we moved on to contrast enhancement for each image quality, and then recovery of data loss in the image. And for image enhancement, we used I used adaptive histogram equalization for contrasting and making the images more clearer. So for segmentation, we used K-mean clustering, and there we are changing the adaptive histogram equalized image from the image enhancement, and we are changing it to A and B, which is a term used for color space converting. As you can see in our process, this process of color space conversion. So we used K-mean clustering for that. Then we then after the segmentation, the image is converted into several regions. As a result, it separates the infected areas of the image from the fish image. Then after that, we should be able to go for feature extraction. The model should be able to do that, and then we display the features from which we have extracted in the support vector machine. Yeah, it's the SVM. So the SVM, it's a machine learning supervised algorithm that aims to construct a hyperplane between classes with a margin to classify objects. It's an algorithm, as you can see. It differentiates between the infected class and then the one which is not infected. It draws the lines. Yeah, so that was the algorithm we used, and as you can see, it separated the red ones which are infected from the blue ones which are not infected. So the data set we reviewed, we acquired a data set from the internet. I think the link will be shared down, the reference for validating and testing the model. Then feature extraction techniques, we used statistical features and then gray level concurrency matrix. As you can see here, we are trying to train our model. Where we can input a data set of fish. We are in a building phase. Then the model should be able to process the image, then capture the feature. Then the weighted model should be able to separate the infected fish and the non-infected fish. And then during the deployment phase, we input an image of a fish, then it processed it, it captures the feature vector, because our support vector matrix was trained already. It was able to categorize and differentiate between the infected fish and the non-infected fish. So from the feature extraction, we used two feature extraction techniques, which are already mentioned up. The statistical feature description, where we have the mean, which has its formula. You can see the formula, and where P represents pixels, and then that sign, it I don't know the name, but it represents the grayscale color intensity for each pixel in the infected regions. Then the next one, the PM, it represents the model for the gray color scale intensity of all pixels in the infected areas. So we have the standard deviations. These are the descriptions for the statistical features we extracted from the data. Then standard deviation, variance, kurtosis, and then the skewness. All these will be used when they are differentiating the image, the texture of an image, from of an infected fish from that of a non-infected fish. So, and from those statistical features, an amount of the gray level, the GLCM, the gray level concurrence matrix feature is used here because it's convenient in extracting of texture features from images. Like, it can be able to tell that this part of the image is different from this part of the image. And as you can see down, the fish with the image fish, we fed into the model. It was able to, from the first fish, which was the input, then when they resized it, then when they enhanced the image quality, and then when the k-mean segment of the image happened, you can see that it's able to map and patch through the infected part of the fish, because to know that if the fish is healthy or if not, it has to be able to capture the infected part. That's when it can able to tell. So the GLMC is the one which is used for texture, extraction of texture features from images, and thus by examining, if you can see the relationship between the two, you can see that between the two pixels at a time, an assessment of the intense diversity at the pixel can be executed, that it will be able to look through the smallest pixel to differentiate the fresh fish and then the infected fish. So after then, we had to go for performance evaluation metrics for our model, and there we use the confusion matrix to envision them on the model performance. So as you can see, during a training set, we used 65 images of different fish, and then of infected fish, the one which had the infections. During a training set, we used 65 images of different fish, and for the non-infected, we used 40 different images. Then during testing, when we are testing the model, we used 22 images of infected fish and 15 images of non-infected fish. The evaluating metrics we used four. One which was accuracy, precision, sensitivity, and specificity. We used all these because they could be able to give us the overall performance of the model. So from the confusion matrix we drew, we were able to classify the performance of the model, and when we calculated the accuracy, we had the accuracy percentage of 76.92% accurate, and that's how the model performed. And then precision, it was 80%, and then sensitivity, it was 66.67%, and then specificity, it was 85.71%. There is the confusion matrix we drew from the model, and then that's it. That's how the model was able to perform. And then the summary, for the segmentation algorithms, we use k-mean clustering, a combination of k-mean clustering and mathematical morphology. Then we use the edge detection and morphological operations. As you can see here in this image, how the edging detection was able, it had to detect the clear path, the edges of the patches of the infection. Then after that, the classifiers, we used the support vector matrix, and then the neural network. Then in conclusion, we are working on a disease detection model, and mainly we classify the fish as either infected or non-infected. We are pleased that our model is new and novel, and its accuracy percentage as per now is 76.92. Thank you.